Okay, so today we introduce a new equation. It's called entropy rate balance equation, which is very straightforward because last time we gave you entropy balance equation, and today it's entropy rate balance equation. Rate means divided by time. So what we do today is just to divide every term in the equation from last time by time. The equation we gave you before was this one. This is for entropy balance equation for a closed system. The equation we gave you last time, it is derivative capital S equal to delta Q over T temperature over the boundary plus delta sigma. Sigma is entropy production. Do you still remember how to understand this equation? Left-hand side is the change of your age, how much you age. And then how much you become older has two reasons. The two reasons are in the right-hand side. The first term is your lifestyle. Do you live healthily or do you not? And the second term in the right-hand side is your metabolism, which cannot be changed. It will always make you become older. Okay, and those two combined together decide how quickly you become older. All right, so this is the equation we gave you last time, and then today it's entropy rate balance equation. The key word here is rate for a closed system. What we do here is very easy. We just divide every term by time. So left-hand side becomes derivative capital S over dt, and right-hand side becomes the whole thing over dt. And the second term in the right-hand side becomes delta sigma over dt. Just divide every term by time. Okay, and then let's continue. If we say the temperature T at the boundary is a constant. In other words, the T here is a constant on the boundary. Doesn't matter where you look on the boundary, the value of the temperature is always the same. We can call it TB, and then this equation just can be simplified. Left-hand side will still be ds over dt, and right-hand side 1 over dt. Still keep it. And this time delta Q. Q will just be the heat transfer, but divided by TB alone. Because temperature is the same, you have the same denominator, so you can just change it to TB instead. And then plus delta sigma over dt. Okay, so now let's take a look. What do we have here? What we have is delta Q over dt. What is that? Q over time. Heat transfer over time. That is called heat transfer rate. So those two terms combined together is just heat transfer rate, which is Q dot divided by TB. And then right-hand side, the second term still the same. Sigma over T. We can call it sigma dot. The dot means divided by time. And this is called entropy production rate. Okay, and we just need to do one more step, then we're done. Okay, one more step. So for example, if you have a system like this, it has multiple surfaces. You start from surface 1, 2, 3, and 4, 5, 6, J. If you have multiple surfaces, what's going to happen to the right-hand side? You can rewrite it to Q1 dot over TB1 plus Q2 dot over TB2 plus every single surface TBJ till the very last one, and then add the last term sigma dot. So now we can combine everything here into sigma. So left hand side derivative capital S over dt equal to first term in the right hand side will become sigma q dot j over tbj. J means the number of the surface. J starts from 1 and ends at n. N means the total number of surfaces you have in the system. Second term in the right hand side, sigma dot. Okay, sigma dot has a name. It's called entropy production rate.